A rock of mass m is thrown horizontally off a building from a height h as shown. The speed of the rock as it leaves the thrower's hand at the edge of the building is v naught. What is the kinetic energy of the rock just before it hits the ground? This is based on the law of conservation of energy. Initial energy must be equal to the final energy. The system's energy will be conserved. Here, the rock has the gravitational potential energy because it is at a height of h. So Ug is equal to mgh. And then it is traveling with a velocity of v naught. Therefore, it has the kinetic energy, which is half mv naught square. So initial energy of the system is mgh plus half mv naught square. And it leaves the thrower's hand and falls below the falls down and then hits the ground. We have to find out the kinetic energy just before it hits the ground. Okay. So the kinetic energy, whatever the kinetic energy here, what is happening as it is coming down, the kinetic energy increases, velocity increases. No, as the object falls down, its velocity increases. So the kinetic energy increases. As the kinetic energy increases, what happens to the potential energy? Potential energy decreases. So the total kinetic energy increases. Just before touching the ground, the potential energy becomes almost zero. By the time it touches the ground, the potential energy becomes zero. And then, of course, the total energy of the system becomes zero because it is coming to rest. But just before touching the ground, the object has only kinetic energy, a small amount, a fraction of amount of potential energy. Entire energies of the kinetic energy. So this is the value. Okay, because there are no other values. It is not mgh. It is not half mv naught square. Okay, and then it is not half mv naught square minus mgh. So this is the initial energy. So the final energy is also like this one, and this is not this one. So the total energy of the system is this one. So the mgh also gets converted into kinetic energy. This also gets converted into, instead of v naught, we have to put vf. Okay, remember, as the object goes down, coming down under the free fall, the velocity increases. So the kinetic energy increases. How much it increases? The same amount, whatever the amount of potential energy it loses, the same amount of kinetic energy the object gains. That is the answer for this question. Next question. A constant force of 900 Newton pushes a 100 kg mass up the inclined plane shown above at a uniform speed of 4 meters per second. The power developed by the 900 Newton force is most nearly. We know power is equal to rate of doing work. Therefore, P is equal to W by T. And we know velocity V is equal to D by T. Distance over time. Am I right? Or displacement over time. So here, W is equal to F dot D. And then displacement over time. Here, power is equal to F dot D by T. No? So we are taking the D by T as V. And then here, because the data is force and velocity. So multiplying, we will get the answer 3600 watts. And then here, this is the answer. This is a simple substitution, nothing beyond that. That's it. Hope this helps. Thank you. Bye-bye.